Alright, so this short video module is going to discuss ANOVAs. Before I need to say that I have no knowledge of your course, I'm not affiliated with any program, and in other words, I have no knowledge of your exam. This is for general knowledge purposes only. We can start with an overview of the ANOVA. So ANOVA stands for Analysis of Variance, it's an acronym, and ANOVA tests are used to test for the possible difference between the group means of a sample. So if you think this sounds a bit similar to independent samples t-test, you would actually be correct. The only difference between an ANOVA and a t-test is that an ANOVA involves more than two means, whereas an independent samples t-test only involves two means. So an ANOVA is kind of like a very fancy t-test where you don't have to worry about increasing your error through multiple comparisons. So we have a couple options if we want to perform an ANOVA. We have the one-way ANOVA and we have the two-way ANOVA. So one-way ANOVA is used when we have one independent variable and two dependent variables. So hopefully you know the difference between an independent and a dependent variable by now. And we can consider an example of a one-way ANOVA situation where we want to consider the relationship between the dosage of a new drug, a novel drug, and its circulating serum levels or levels in the bloodstream. So we can see here we have the dosage given to a variety of patients and their circulating serum levels, which we see here. Now, this ANOVA is going to look at the independent variable of dosage, which has multiple levels, and compare it to the dependent variable or the circulating serum levels. So we'll need to use an ANOVA here because we're hoping to calculate what looks like three different means based on this different levels of the dosage or the independent variable. The other type of ANOVA we can perform is a two-way ANOVA, which uses two independent variables and probably one dependent variable. So two-way ANOVAs can be used to look at interaction effects between two independent variables, or whether the variables influence each other and influence the outcome. So an example might be if you're familiar with the term of synergistic drugs, or drugs which work together to produce an outcome far superior to anything that they might have given separately, or even what you would expect given the sum of their treatments or their outcomes. So an example of a two-way ANOVA we can look at is the relationship between HIV status, presence of a college degree, or whether or not the person has earned a college degree, and their annual income. So we can see here that HIV status and educational status as defined by possession of a college degree, two independent variables, and here we have our dependent variable. So as with almost all statistical tests, we can perform ANOVAs by hand or with a computer. And before we begin our test, however, we're going to have to take a look at some of the assumptions we need for an ANOVA. So the first one is that samples are independent. It kind of goes without saying. Don't have matched pairs, don't have twins, readings from the same person. Everything has to be independent. Variances are equal. Between the groups, residuals are normally distributed, or errors are normally distributed, and dependent variables are continuous. So the first three should come out correctly if you have enough people in your sample population and so on and so forth. The last one, just remember that dependent variables have to be ratio or I can't remember the word right now. Ratio and interval. So you can't have any kind of ordinal categorical data when you're in your dependent variable when you're doing an ANOVA. So if we were to do an ANOVA in SPSS, this is what our SPSS screen might look like. So you can see we're going to use the same menu as we did for the t-test. Right here, ANOVA, we're going to be asked to describe the dependent and independent variables. Now, if we're interested in doing a two-way ANOVA, we'll have to use a slightly different menu. Again, we'll be asked to define the dependent and independent variables. We can also do an ANOVA on Excel using this data analysis toolbar, which we can add in by making a couple adjustments to our Excel, and the readout will be similar to that of SPSS. So if we wanted to do an ANOVA by hand, we would have to come up with an ANOVA table similar to the one seen on the screen. Now, in doing a one-way ANOVA table, it's going to look something like this. But we'll see we're dividing our whole table by the source of error, so whether the error is between groups or within groups. Now, between groups error is sometimes seen as the error of the factor or the variables, whereas this within groups error. Yes, sorry. Let me rephrase that. Between groups variability is variability between the factors, whereas within groups variability is the error or unexplained random error within the specific variable. And then total refers to the total everything. Over here we can see we're also going to calculate the sums of squares, the degrees of freedom, the mean sum of squares, the F statistic, and the p-value. Now we can see the formulas here. So for example, the mean square is the sums of squares divided by the degrees of freedom. The F statistic is the mean square, this mean square of between groups divided by the within groups means of square. And it's very important to note that this F statistic is not your p-value. You need to take the F statistic, look it up on a table to find your p-value. Don't make the mistake of thinking that your F value is your p-value, because it is not. So this is a two-way ANOVA table, kind of similar to the one-way ANOVA table. The only difference we see is an added source of variation for the additional independent variable group, which we have added to the two-way ANOVA. Now, if we perform a ANOVA in SPSS, this particular one, as you can see here, would be a one-way ANOVA. We're going to get a readout similar to this one. And we can see that the entire table has already been completed, and our significance or p-value has actually already been calculated for us, which is nice. And this p-value, as you might be able to tell, of 0.006 is extremely small, and in almost all cases would be seen as significant. So now, because this particular topic reminds me of a Blondie song, I've modified the song slightly for your torture, if you will. Now this microphone is very bad, so please excuse my singing and the music as well. I had the option of doing guitar chords or karaoke from an online YouTube video. So I wasn't sure which one would sound worse. The karaoke version from YouTube kind of it's a bit off in the beginning, but hopefully we'll be able to work through it together. And please sing as soon as you get the tune, because then you can drown out my voice and enjoy the song a whole lot more than you would just listening to me. Okay, so here it goes. One way or ANOVA, I'm gonna find P. I'm gonna find it. One way or ANOVA, I'm gonna find it. I'm gonna find it. One way or ANOVA, I'll find what F is. I'm gonna do it. One way or ANOVA, I'll fill a table. I'm gonna fill it. I'll do it. I will use SPSS to find the group differences and figure out P. One way or ANOVA, I'm gonna find P. I'm gonna find it. One way or ANOVA, I'm gonna find it. I'm gonna find it. One way or ANOVA, I'll find what F is. I'm gonna do it. One way or ANOVA, I'll fill a table. I'm gonna fill it. I'll do it. I will use SPSS to find the group differences and figure out please. One way or ANOVA, I'm gonna find peace. I'm gonna find it. One way or ANOVA, I'm gonna find it. I'm gonna find it. One way or ANOVA, I'll find what F is. I'm gonna do it. One way or ANOVA, I'll fill the table. I'm gonna fill it. I'll do it. So that's enough of that. I'm sure you've had enough of that. So that concludes this particular video module. And again, if you see any mistakes, if you have any concerns or questions, please let me know. This is probably full of mistakes, but hopefully it served as a bit of a review, just to give you the basics of what ANOVA is, what we can use it for, how it works.